In this section, we're going to look at speed and velocity. So first of all, average speed, we're looking at the distance traveled divided by the time that they're traveling. So typically speed is going to correspond with distance because there's not usually a direction involved. And velocity will correspond with displacement because there would be a direction involved. So the equation that we'll use will be speed equals distance over time. And again, this is a scalar quantity. So for average velocity, here we're doing displacement divided by time. So our v, or velocity, is going to be change in distance divided by change in time. And this will most often be measured in meters per second because those are the SI units. But a lot of times we'll just be able to use distance over time because that will be kind of interchangeable for speed and velocity. Instantaneous velocity is looking at the velocity of an object at one particular time over a trip. So if we were looking at driving maybe from Anna to Carbondale, we might say that the average speed that we traveled was 55 miles per hour. But at some point we had to speed up to that. So maybe, when we were starting, we were going 20 miles per hour. Maybe on the highway we went a little faster and we were going maybe 62 miles per hour. So those specific points would be instantaneous, whereas the 55 might be our average for the whole trip. As we look at some of these example problems, we're going to be using velocity equals distance over time. So if we look at this first one, it says we have a jogger run 1.5 hours, which is the same as 5,400 seconds. So that's our time. And then he has an average speed, which will interchange speed and velocity as we do these. So our V is going to be 2.2 meters per second. Now, one thing that we have to be aware of are our units. So if we look at our velocity, it's in meters and seconds, and then we were given the time in hours and seconds. So when we set this up, we're going to use the same units throughout. So if our V is 2.2 meters per second, we want to use the 5,400 seconds, and then our distance that we're looking for will be in meters. So if we take 2.2 times the 5,400, we end up with 11,988 meters for our answer. In this next problem, it says you step onto a hot beach with your bare feet. A nerve impulse travels through your nervous system at an average speed of 110 meters per second. So that's our velocity. It's always best to go ahead and write down, make a list of the variables that you know. So V is 110 meters per second. How much time, so we're looking for time, does it take for the impulse, which travels a distance of 1.8 meters, to reach your brain? So if we set this up, velocity of 110 meters per second equals our distance of 1.8 meters over a time. And since we have meters, and then our time is going to be in seconds. So we will take 1.8 divided by 110, and our time equals 0.016 seconds. Now, one thing I find that a lot of people struggle with, when you have an equation set up with something equals a number over your variable, a lot of people have trouble remembering, do I multiply, do I divide? So something that I would write down would be 3 equals 6 over 2. And so if I look at that equation, if I were trying to solve for, let's say, the 2, and I had the 6 and 3, but I didn't have the 2, I would take 6 divided by 3 to get the 2. And we can see that that would be a true statement. Or let's say if I was looking for possibly the 6. Well, I would take the 3 times the 2 to get the 6. So if I just write down the 3 equals 6 over 2, if I'm trying to solve something like that, I can compare and know, okay, I know this statement's true, so how would I solve, a problem that I might be unsure of? This next problem says a young runner can complete a 10-kilometer course with an average speed of 4.39 meters per second. An older runner can cover the same distance with an average speed of 4.27 meters per second. How much later should the younger runner start in order to finish the course at the same time? So we really have a couple different problems here. We have to figure out the time it takes the young runner to complete the 10K course and then the older runner, and then we're going to have to find the difference. So first of all, the distance that they're covering is 10 kilometers. The younger runner is going to have a speed of 4.39 meters per second, and the older runner has a speed of 4.27 meters per second. Now, one of the first things we have to do is look at our units. The speeds are in meters per second and the distance is in kilometers. So we need to get that kilometers in meters. So if we do kilometers, 1 kilometer is 1,000 meters. So this is going to be a 10,000 meter course. So then for the younger, we're going to do the velocity is 10,000 meters over the time. And then the same thing for the older, 10,000 over the time. So if we solve the time, for the younger, we're going to do 10,000 divided by 4.39. Time would be 2,277.9 seconds. And then for the older runner, 10,000 divided by 4.27, we get a time of 2,341.9 seconds. So now the problem, though, if we look back, says how much later should the younger runner start in order to finish the course in the same time. So we really are just looking for the difference in their time. So if we look back, if we take the 2,341.9 seconds minus the 2,277.9 seconds, the difference between those two is going to be 64 seconds. So if the younger runner starts 64 seconds later, then the two would finish at the same time. In this next problem, it says we have a space shuttle traveling at a speed of about 7.6 times 10 to the third meters per second. So V equals 7.6 times 10 to the third meters per second. The blink of an astronaut's eye lasts about 110 milliseconds. How many football fields does the shuttle cover in the blink of an eye? So our time is at 110 milliseconds. So if we need to find the distance that is covered, and then we'll have to figure out how many football fields that is. So if we write a field is 91.4 meters. So we've got our velocity we're looking for our distance over time. But again, in the top, the velocity is in seconds, and our time is in milliseconds. So if we change milliseconds to seconds, and again, use your conversion chart if you need to, this is going to give us 0.11 seconds. So now at this point, we can put our time in our equation, 0.11 seconds, and solve for the distance. So here we'll multiply the 7.6 times 10 to the third times 0.11 seconds, and our distance turns out to be 836 meters. Now that's how much distance it will cover, but the question asks, how many football fields is that? So we're going to divide that by the 91.4, which is the length of a football field. So 836 meters divided by 91.4 is going to give us 9.15 fields that would be covered. In this next problem, we have a three-toed sloth, slowest moving land mammal, and it has an average speed of 0.037 meters per second. So the sloth has a velocity of 0.037 meters per second. And then we also have a giant tortoise with a velocity of 0.076 meters per second. It says, after 12 minutes of walking, how much further would the tortoise have gone relative to the sloth? So we've got their time of 12 minutes, which we need to get in seconds. So minutes, 1 minute is 60 seconds. And if we take 12 times 60, that's going to give us 720 seconds. So we need to figure out how far each animal has gone. So we'll take their velocity equals distance over the time of 720 seconds. So the sloth, if we take 0.037 times 720, would go 26.64 meters. And the tortoise, 0.0676 times 720, would go 54.72 meters. Now if we look back at the problem, it says, how much further would the tortoise have gone relative to the sloth? So now it wants us to subtract. So 54.72 minus 26.64. And that gives us a difference of 28.08 meters for our final answer. Here we have a rocket travels at 19,500 miles in just 45 seconds. So our distance is 19,500 miles in a time of 45 seconds. What is the speed of the rocket in miles per hour during the 45 seconds? So here we have miles per second. So we need to change this seconds to hours. So 1 hour is 3,600 seconds. So if we do 45 divided by 3,600, we get 0.0125 hours. So now to find our velocity, we'll take the distance of 19,500 over 0.0125 hours. This was miles. And then we're ready to divide. 19,500 divided by 0.0125 is going to give us 156 with 4 zeros. So 1,560,000 miles per hour. In this problem, it says a school bus travels for 50 kilometers per hour for 45 minutes. How far did the bus go? So velocity is 50 kilometers per hour for 45 minutes. And we're looking for distance. So if we've got 45 minutes, we need that in hours. 1 hour is 60 minutes. So that's going to give us 0.75 hours. So then we'll take our 50 kilometers per hour is going to equal distance over 0.75 hours. So the distance turns out to be 50 times 0.75 or 37.5 kilometers. 30 years ago, police would check a highway for speeders by sending a helicopter up in the air and observing the time it would take for a car to travel between two wide lines placed 1/10 of a mile apart. On occasion, the car was observed to take 7.2 seconds to travel this distance. First, how much time did it take the car to travel the distance in hours? So we have the 1/10 of a mile as a distance. And we've got a time of 7.2 seconds. This just says how much time did it take the car to travel the distance in hours. So really all we're doing at this point is we're going to convert the seconds to hours. So 3,600 seconds in 1 hour is 0.002 hours. If we look at the next question, it says, what is the speed of the car in miles per hour? So if we've got a distance of 0.1 mile and a time of 0.002 hours, if we divide that out, we get 50 miles per hour. In this problem, it says the fastest trains are magnetically levitated above the rails to avoid friction. The fastest trains travel about 155 miles in a half an hour. What is their average speed in miles per hour? So if their distance is 155 miles, and that's in a half an hour, so time is 0.5 hours. Then we need to just divide those out. 155 miles, 0.5 hours, and that's going to give us 310 miles per hour. In this last problem, it says the record for the fastest and longest skydive was 19.5 miles. So we'll write that down. And the average speed or velocity is 254 miles per hour. We want to know how much time did the dive last. So if our velocity is the 254 miles per hour and our displacement was 19.5 19.5 miles. Then we are looking for our time. So 19.5 divided by 254. Our time turns out to be 0.077 hours. Now, to me, I don't really have a concept of how long that is. I know it's a short amount of time, but let's switch that to minutes. So 1 hour is 60 minutes. And if we multiply that out, we get 4.6 minutes that this guy was falling through the sky.